September 14th, 1944. Captain Robert Anderson sat in the cockpit of his P-51D Mustang at 38,000 feet over Bavaria, watching a formation of German reconnaissance aircraft cruise lazily above him at what his altimeter suggested was 41,000 feet. They were untouchable. His engine was already gasping for air at this altitude, the Packard Merlin straining against the thin atmosphere. If he tried to climb another 3,000 feet, his aircraft would stall, tumble, and he would become an easy target for any Luftwaffe fighter patrolling below. The Germans knew it. The Americans knew it. At altitudes above 40,000 feet, the Luftwaffe owned the sky. Their specially modified Messerschmitt Bf 109s and Junkers Ju 86s operated in a realm where American fighters could not follow, photographing Allied positions, tracking convoy movements, radioing bomber formations with impunity. It was humiliating. More than that, it was deadly. Intelligence estimates suggested that German high-altitude reconnaissance was responsible for directing attacks that had cost hundreds of Allied lives. Anderson gripped his control stick, his leather gloves creaking against the worn grip. He had been flying combat missions for 8 months. Shot down 2 Bf 109s, damaged 3 others, survived more close calls than he cared to remember. But he had never felt as helpless as he did right now, watching enemy aircraft operate beyond his reach, knowing there was nothing he could do about it. 3,000 feet might as well have been 300 miles. The air at 41,000 feet was so thin that conventional superchargers could not compress enough oxygen to keep engines running at combat power. The Packard Merlin V1650 was a magnificent engine, one of the best piston engines ever built, but it had its limits. And those limits stopped at around 38,000 feet of effective combat ceiling. Anderson keyed his radio. Tomcat leader, this is Tomcat 3. Target is at Angels 4 to 1, repeat 4 to 1,000. I cannot engage. Repeat, cannot engage. The response was terse, frustrated. Roger, Tomcat 3. Return to patrol altitude. We'll log it for intelligence. Anderson pushed his stick forward, beginning a shallow descent back to 30,000 feet where his engine could breathe properly, where he could actually fight if enemy fighters appeared. As the altimeter unwound, he thought about the briefing that morning. Colonel Marcus had been blunt. Gentlemen, the Germans are beating us at high altitude. Their reconnaissance birds are mapping every convoy route, every airfield, every ammunition depot from 40,000 feet up. We've tried everything. High-altitude intercepts, standing patrols, radar vectoring. Nothing works because we simply cannot get our fighters up there with enough power to engage. One of the younger pilots, a lieutenant fresh from stateside, training, had raised his hand. Sir, what about the B-29? That operates at high altitude. The B-29 is a bomber, Lieutenant, with a crew of 11 and turbo superchargers the size of oil drums. It is not a fighter. We need something that can climb, maneuver, and fight at 40,000+ feet. Right now, we do not have it. But someone, somewhere, was working on exactly that problem. And the solution would come not from engineers in comfortable laboratories, not from aircraft designers with unlimited budgets, but from a mechanic in England who was about to break every regulation in the Army Air Force's technical manual. If you are enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Technical Sergeant James McKinley was not supposed to be modifying engines. His job, as defined by his Army Air Force's manual, was to maintain and repair aircraft according to strictly specified procedures. Deviations from approved maintenance protocols were forbidden. Unauthorized modifications could result in courts-martial. The reasoning was sound. In combat, you needed standardization. You needed to know that every P-51 performed identically, that replacement parts would fit perfectly, that pilots could transition between aircraft without retraining. But McKinley, a former auto mechanic from Detroit who had spent his teenage years racing modified cars on dirt tracks outside the city, had never been good at following rules when he knew a better way existed. and he was absolutely certain that a better way existed for the Packard Merlin engine. The problem was well understood by anyone who knew piston engines. As altitude increased, air density decreased. Less dense air meant less oxygen for combustion. Less oxygen meant less power. Superchargers solved this problem by compressing incoming air, forcing more oxygen into the cylinders than would naturally exist at high altitude. The Packard Merlin used a two-stage, two-speed supercharger, an incredibly sophisticated system for 1944. But even this advanced design had limits. The issue was heat. When you compressed air, you heated it. Hot air was less dense than cold air, which partially defeated the purpose of compression. The Merlin used intercoolers to cool the compressed air before it entered the engine, but at extreme altitudes, the system reached its thermal limits. You could not compress the air any further without heating it so much that you lost the density advantage, unless you changed something fundamental about how the supercharger operated. McKinley had been thinking about this problem for months, ever since his squadron had started encountering German high-altitude reconnaissance aircraft they could not intercept. He had read every technical manual he could get his hands on, borrowed engineering textbooks from a friendly British RAF mechanic, spent his off-duty hours sketching designs in a battered notebook. The solution, he believed, lay in increasing the intercooler efficiency and modifying the supercharger's impeller geometry to provide greater compression at high altitude without generating excessive heat. It would require machining new impeller blades with a slightly different pitch, enlarging the intercooler surface area, and adjusting the fuel mixture to accommodate the increased air density, all of which was completely unauthorized. In late September 1944, McKinley made his decision. He was going to modify an engine, without permission, without approval, and he was going to do it in a way that, if it failed, would almost certainly get him court-martialed. He chose his aircraft carefully. P-51D, serial number 4-14826, had just returned from a mission with minor battle damage. A few bullet holes in the fuselage, nothing structural. It would be in the maintenance hangar for at least 3 days while the sheet metal crew patched the damage. That gave McKinley 3 days to work. He started after midnight, when the hangar was nearly empty. Just him, the night security patrol, and one other mechanic working on a different aircraft at the far end of the building. McKinley pulled the cowling off the Merlin, exposing the massive engine, all 12 cylinders and 2 supercharger stages gleaming in the harsh electric light. First, he removed the intercooler assembly. This was standard maintenance, nothing suspicious. But instead of cleaning and reinstalling it, he carried it to his workbench and began modifications. Using a borrowed milling machine, he carefully cut additional cooling fins into the aluminum casing, increasing the surface area by approximately 20%. More surface area meant more heat dissipation, which meant cooler compressed air, which meant denser air entering the cylinders. The work was delicate. Cut too deep and you would weaken the structure. Cut too shallow and the additional cooling would be insufficient. McKinley worked slowly, checking measurements obsessively, his hands steady despite the knowledge that he was destroying a piece of military equipment worth more than his annual salary. By 300 hours, the intercooler modification was complete. He moved to the supercharger itself. The impeller, the spinning component that actually compressed the air, was precisely machined from forged aluminum. Changing its geometry was extremely difficult. You could not simply grind new shapes into the blades. Any imbalance would cause catastrophic vibration at operational speeds, potentially destroying the entire engine. But McKinley had an idea. Instead of modifying the existing impeller, he would replace it with one salvaged from a damaged engine, then carefully adjust the blade angles using heat and precision bending. It was a technique he had learned building racing engines in Detroit, not something taught in any military manual. He found what he needed in the salvage pile, an impeller from a Merlin that had ingested a bird, destroying several cylinders, but leaving the supercharger mostly intact. He spent the next 4 hours carefully heating individual impeller blades with a torch, bending them microns at a time, checking balance on a makeshift rig he assembled from spare parts. By dawn, he had what he believed was a functioning high-altitude impeller. The blade angles were steeper than standard, designed to provide greater compression at the cost of slightly reduced efficiency at lower altitudes. It was a trade-off. The modified engine would perform marginally worse below 20,000 feet, but significantly better above 35,000 feet, if it worked. If it did not work, the engine would either produce no additional power at altitude, making all this effort pointless, or it would overheat catastrophically, possibly catching fire in mid-air and killing whoever was flying the aircraft. McKinley tried not to think about that second possibility. He reassembled the engine with his modified components, working through the morning and into the afternoon. By 1600 hours, everything was back together. The cowling was secured. The aircraft looked exactly like every other P-51D on the flight line, but inside that cowling was an engine that no longer met Army Air Force's specifications, an engine that McKinley desperately hoped would let American pilots reach 40,000 feet with combat power. Now came the hard part, testing it without getting caught. McKinley needed a pilot who would not ask too many questions, someone experienced enough to handle potential engine problems at high altitude, someone he trusted. He found that person in Captain Robert Anderson. Anderson and McKinley had known each other for 6 months, ever since Anderson had transferred to the squadron. The captain made a habit of talking to his crew chief before and after every equally faces mission, asking technical questions, wanting to understand exactly how his aircraft performed and why. Most pilots treated mechanics as interchangeable parts of the military machine. Anderson treated them as colleagues who knew things he did not. McKinley found Anderson in the officers' mess that evening, eating dinner alone, reading a maintenance manual. The captain was that kind of pilot, always trying to learn more about his aircraft. "Captain Anderson, sir. Got a minute?" Anderson looked up, set down his manual. "McKinley, what's on your mind?" "Your bird is ready, sir. The one that took damage last week. 44-14826. I've made some modifications." Anderson's expression sharpened. "Modifications? What kind?" McKinley glanced around. The mess hall was crowded, too many ears. "Maybe we could discuss this outside, sir." They walked out into the September twilight, away from the buildings, toward the flight line where they could speak, privately. McKinley explained what he had done, speaking quickly, technically, using the precise language of engineering to describe impeller geometry and intercooler efficiency. Anderson listened without interrupting. When McKinley finished, the captain was quiet for a long moment, his face unreadable in the fading light. "You are telling me," Anderson said carefully, "that you have installed unauthorized modifications to an Army Air Force's fighter aircraft without permission from Engineering Command." "Yes, sir." "Modifications that could potentially cause engine failure at high altitude." "They could, sir. But I do not believe they will. I have calculated the thermal loads, checked the balance, tested everything I could test on the ground." "But you have not flown it." "No, sir. I need a pilot for that." Anderson looked toward the flight line, toward the rows of Mustangs sitting silent in their revetments, beautiful aircraft that could not quite reach the altitudes where they were most needed. "If this works," Anderson said slowly, "we could intercept those reconnaissance birds. We could reach 40,000 feet with enough power to fight." "That is the idea, sir." "And if it does not work? Then I go to the stockade and you write a report about engine failure due to faulty maintenance." Anderson smiled, a tight, dangerous smile. "Sergeant McKinley, you are asking me to test fly an aircraft with unauthorized engine modifications that could kill me." "Yes, sir, I am." "When do we fly?" They chose dawn, when visibility would be good and the flight line would be busy enough that one more P-51 taking off would not attract special attention. McKinley had logged the aircraft as ready for post-maintenance test flight, standard procedure. No one would question it unless something went wrong. Anderson strapped into 4-14-826 at 05:30 on September 28, 1944. McKinley stood beside the cockpit, going through the pre-flight checklist with unusual intensity. "Sir, If you experience any unusual vibration, any overheating, anything that does not feel right, you shut down immediately and glide back. Do not try to push through it. Understood. The modified supercharger should engage normally when you advance the throttle. You will not feel any difference below 20,000 feet. Above that, she should start pulling stronger than a standard bird. How much stronger? I do not know, sir. That is what we are about to find out. It caught on the second try, settling into the familiar deep-throated rumble of 12 cylinders running in perfect synchronization. Oil pressure good, coolant temperature rising normally. Everything looked standard. He taxied to the runway, received clearance from the tower, and opened the throttle. The Mustang accelerated smoothly, lifting off after barely 500 feet. Gear up, flaps up, climbing, through 1,000 feet in the cool morning air. At 10,000 feet, everything still felt normal. The engine purred. The controls responded crisply. Anderson began to relax slightly. Maybe McKinley's modifications would work. Maybe they would fail harmlessly. Either way, the immediate fear of catastrophic failure was fading. At 15,000 feet, he leveled off and performed some basic maneuvers. Rolls, loops, high-speed passes. The aircraft handled exactly like every other P-51 he had flown. The engine temperatures were normal, perhaps even slightly cooler than usual. At 20,000 feet, he began to notice something different. The engine seemed to have more reserve power than he was accustomed to at this altitude. When he advanced the throttle, the response was crisper, stronger. It was subtle, but definitely present. At 25,000 feet, the difference became pronounced. Standard P-51 seconds at this altitude were working hard, engines straining against the thin air. But 44-14826 was pulling smoothly, powerfully, like it was still at 15,000 feet. Anderson checked his instruments obsessively. Engine temperature normal, oil pressure normal, manifold pressure slightly higher than standard, but not dangerously so. The supercharger was doing exactly what McKinley had promised, compressing more air without generating excessive heat. At 30,000 feet, Anderson was grinning inside his oxygen mask. This was working. This was actually working. At 35,000 feet, where standard P-51 seconds were approaching their combat ceiling, barely able to maintain level flight with combat power, 44-14826 was still climbing strongly. The rate of climb had decreased, certainly, but the engine was still producing substantial power. Anderson pushed higher. 36,000, 37,000, 38,000. The altimeter kept winding upward. The air outside was viciously cold, minus 50 degrees Fahrenheit. But inside the cockpit, Anderson was sweating with excitement. At 39,000 feet, he felt the first signs of the aircraft approaching its limits. The controls were getting mushy, the wings were barely generating enough lift in the thin air. But the engine was still running smoothly, still producing power. He pushed to 40,000 feet. The altimeter touched 40000. Anderson held it there for a full minute, checking every instrument, feeling every vibration through the control stick. The engine temperature was elevated, but within acceptable limits. The supercharger was screaming, forcing air into the cylinders at maximum compression. But everything was holding together. Then he pushed higher still, 41,000 feet, 41,500, the altitude where German reconnaissance aircraft operated with impunity. At 41,900 feet, Anderson finally felt the aircraft reach its absolute limit. The wings were barely flying, the control surfaces barely responded. Any higher, and he would stall, tumble, potentially go into an unrecoverable spin. But he was here. An American fighter at almost 42,000 feet with enough power to maneuver, to fight. McKinley's modifications had worked. Anderson throttled back and began a careful descent. As he dropped through 30,000 feet, back into thicker air, he keyed his radio. Tower. This is Tomcat 3. Requesting permission to make one more climb to altitude for additional testing. Roger, Tomcat 3. You are cleared for additional high-altitude testing. Report any anomalies. Anderson climbed again, this time testing combat maneuvers at extreme altitude. Turns, rolls, simulated attack runs. The aircraft performed beautifully, far better than any P-51 had ever performed at these altitudes. McKinley had not just modified an engine, he had created something new, a high-altitude fighter that could go anywhere the enemy went. When Anderson finally landed and taxied back to the revetment, McKinley was waiting, his face tight with anxiety. "Well, sir." Anderson climbed out of the cockpit, pulled off his oxygen mask, and looked at the sergeant for a long moment. 41,900 feet, Sergeant. Combat power maintained throughout. Engine temperature nominal. No vibration, no overheating, no problems whatsoever. McKinley's knees nearly buckled with relief. It worked. It actually worked. It worked. We need to show this to Colonel Marcus immediately. This changes everything. But presenting an unauthorized engine modification to the squadron commander carried its own risks, risks that would determine whether McKinley became a hero or a prisoner. Colonel William Marcus was not a man easily impressed. He had flown P-42s in North Africa, survived 3 crash landings, and commanded a fighter squadron through some of the bloodiest air battles over Europe. He had seen every kind of pilot and every kind of mechanic. The good ones, the mediocre ones, and the dangerously incompetent ones who got people killed. When Captain Anderson and Sergeant McKinley appeared at his office door at 0800 hours on September 28th, requesting an urgent meeting, Marcus assumed it was about another maintenance delay or a personality conflict. Squadron command involved far more paperwork and personnel management than actual flying, and most urgent meetings turned out to be neither urgent nor particularly important. "Come in, gentlemen. What's this about?" Anderson glanced at McKinley, then back at the colonel. "Sir, we have something to show you. It's regarding high-altitude performance." Marcus set down the readiness report he had been reviewing. High-altitude performance was a subject that got his attention. The Germans were eating their lunch above 40,000 feet, and he had been receiving increasingly sharp inquiries from Group Command about why his squadron could not intercept reconnaissance aircraft that were clearly visible to ground observers. "I'm listening." "Sir, Sergeant McKinley has developed modifications to the Packard Merlin supercharger system that significantly extend our combat ceiling. I test flew the modified aircraft this morning and reached 41,900 feet while maintaining combat power." Marcus stared at them. "You reached what altitude?" 41,900 feet, sir, approximately 4,000 feet above our standard combat ceiling. The engine performed flawlessly throughout the test. The colonel turned his attention to McKinley. "Sergeant, are you telling me you've modified an engine?" "Yes, sir." McKinley's voice was steady despite the obvious tension in his shoulders. "I altered the supercharger impeller geometry and enlarged the intercooler surface area. The modifications provide increased compression at high altitude without excessive thermal build-up. Without authorization." "Yes, sir. Without authorization." Marcus leaned back in his chair, his expression unreadable. The book said he should have McKinley arrested immediately. Unauthorized modifications to military equipment, especially to something as critical as a fighter aircraft engine, violated multiple regulations. If the engine had failed during Anderson's test flight, if the captain had been killed, McKinley would be facing charges that could result in a lengthy prison sentence. But Marcus had not survived this long by blindly following regulations when reality suggested a different course. If what Anderson was claiming was true, if they really had a P-51 that could operate effectively above 40,000 feet, that changed everything. "Captain Anderson, you're certain about this performance?" "Absolutely certain, sir. I have detailed notes on every phase of the flight. Altitude, engine temperature, manifold pressure, rate of climb. I also performed combat, maneuvers at altitude. The aircraft handles well, far better than standard birds at that height." Marcus stood up and walked to his window, looking out at the flight line where dozens of Mustangs sat in their revetments. His squadron, his responsibility. He could play it safe, follow the regulations, have McKinley arrested, and the modified engine removed. That would protect his career if something went wrong. Or he could take a risk. He could recognize that sometimes the best solutions came from unexpected places, from mechanics who saw problems that engineers missed, from people willing to break rules for the right reasons. Sergeant McKinley, I'm going to ask you a question, and I want an honest answer. Are you confident these modifications are safe? McKinley met the colonel's eyes. Sir, I've checked every calculation 3 times. I've balanced the impeller to within tolerances tighter than factory specifications. I've stress-tested the intercooler welds. The theoretical basis is sound, and Captain Anderson's test flight proved the concept. Yes, sir. I'm confident they're safe. But they're not approved by Engineering Command. No, sir. They're not. Marcus made his decision. Here's what we're going to do. Captain Anderson, you'll make 2 more test flights over the next 2 days. High altitude profile, varying conditions. I want comprehensive data on engine performance, fuel consumption, temperature management, everything. Sergeant McKinley, you'll document your modifications in complete technical detail, specifications, measurements, the works. He turned back to face them. If those test flights confirm Captain Anderson's initial results, I'm taking this to Group Command, and I'm recommending that we modify every P-51 inches this squadron. Is that understood? Yes, sir, they said in unison. Dismissed. And Sergeant? Sir? If this works, I'm putting you in for a commendation. If it fails and kills someone, I'm putting you in the stockade. Fair enough? Fair enough, sir. Over the next 48 hours, Anderson flew 4 more test missions in aircraft 4-14-8-26. Each flight pushed the modified Mustang to its limits, gathering data that would either vindicate McKinley's work or condemn it. The results were consistent. The modified engine produced approximately 15% more power at altitudes above 35,000 feet compared to standard engines. The combat ceiling increased from roughly 38,000 feet to 42,000 feet. Fuel consumption was marginally higher at extreme altitude but acceptable. Engine temperatures remained within safe operating limits throughout all tests. McKinley spent those same 48 hours documenting everything he had done, creating detailed technical drawings of his modifications, writing procedure manuals that other mechanics could follow. He worked in the corner of the hangar, hunched over a drafting table, translating the intuitive knowledge he had developed through years of hands-on mechanical work into the formal language of engineering documentation. Other mechanics began to notice something unusual was happening. Word spread through the enlisted ranks that McKinley had modified an engine, that Anderson was test-flying it at extreme altitudes, that Colonel Marcus was involved. Speculation ran wild. Some thought McKinley would be court-martialed. Others bet that he was onto something revolutionary. On October 1st, 1944, Colonel Marcus flew to 8th Air Force Headquarters at High Wycombe with a folder full of test data and McKinley's technical documentation. He met with Colonel Donald Blakesley, commander of the 4th Fighter Group, and several engineering officers from the 8th Air Force technical staff. Marcus laid out the data on a conference table. Flight logs showing sustained high-altitude performance, temperature charts demonstrating thermal management, technical, drawings of the supercharger and intercooler modifications. Everything McKinley and Anderson had compiled. The engineering officers were skeptical at first. One major, a career officer who had spent years in aircraft development, was openly hostile. Colonel Marcus, you're telling me that a sergeant mechanic has achieved performance improvements that our best engineers at Packard and Rolls-Royce have been unable to accomplish? That seems highly unlikely. Major, I'm telling you that we have test data from 5 flights demonstrating a 4,000-foot increase in combat ceiling. The data is there. You can analyze it yourself. Another officer, a captain with an engineering degree from MIT, studied McKinley's technical drawings more carefully. This impeller modification is actually quite clever. He's essentially created a steeper compression curve optimized for high-altitude operation, and the intercooler enlargement addresses the primary thermal limitation of the standard, design. But it's not approved, the Major insisted. These modifications haven't been tested under controlled conditions. We don't know the long-term reliability implications. We don't know if they'll hold up under sustained combat stress. Colonel Blakesley, who had been listening quietly, spoke up. Major, we've got German reconnaissance birds photographing every convoy from France to the Low Countries. They're doing it from altitudes we can't reach. How many men have died because those convoys got hit after being spotted? How many bombers have been jumped by fighters that were vectored in by high-altitude reconnaissance? The Major had no answer. Colonel Marcus, Blakesley continued, what's your assessment of this modification? Sir, I believe it works. I've reviewed the data personally. I trust Captain Anderson's flying and Sergeant McKinley's mechanical expertise. More importantly, I think we need this capability. The Germans have beaten us at high altitude for too long. Blakesley looked at the engineering officers. How long would it take to validate these modifications through official channels? The MIT captain thought for a moment. Proper testing and certification? 6 months minimum. Probably closer to a year if we involve Packard and do full engineering analysis. We don't have a year. We probably don't have 6 months. Blakesley made his decision. Here's what we're going to do. Colonel Marcus, you'll modify 6 aircraft in your squadron using Sergeant McKinley's specifications. We'll run them in combat for 30 days. If they perform as advertised without failures, we'll expand the program to other squadrons. If we have problems, we shut it down immediately and go back to standard configuration. Agreed? Marcus nodded. Agreed, sir. The Major opened his mouth to object, but Blakesley cut him off. Major, I appreciate your concerns about proper procedure, but we're fighting a war, and wars aren't won by people who wait for perfect solutions. Sometimes you have to trust the people doing the actual fighting to know what they need. Meeting adjourned. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Back at the squadron, McKinley assembled a team of mechanics he trusted. 5 men who had worked with him long enough to understand his standards, who could follow technical procedures precisely, who would not cut corners even when they were exhausted. He gathered them in the maintenance hangar after dinner on October 3rd. They stood around the workbench, where McKinley had laid out his technical drawings and a set of modified components he had already fabricated. Gentlemen, we've been authorized to modify 6 aircraft. We have 4 days to complete the work. That's less than 24 hours per aircraft, so we'll be working in shifts around the clock. A corporal named Jensen, a farm boy from Iowa, who could disassemble and reassemble a Merlin engine blindfolded, studied the drawings. Sarge, this impeller modification, that's some precise work. We mess up the balance even slightly, we'll have an engine that shakes itself apart at high RPM. I know. That's why we're going to balance every impeller 3 times, and we're going to test each engine on the ground at full power for 15 minutes before we let any pilot take it up. Another mechanic, Private Kowalski from Chicago, asked the question they were all thinking. Sarge, what happens if one of these modified engines fails? What happens to us? McKinley looked at each of them in turn. If an engine fails due to defective work, due to sloppy procedures or missed steps, then I take responsibility. It's my design, my specifications. But if an engine fails because you didn't follow the procedures exactly, because you took shortcuts or rushed the work, then that's on you. So I'm asking you now, before we start, are you willing to do this right, even if it means working all night, even if it means checking the same measurement 5 times? They all nodded. These were men who took pride in their work, who understood that pilots' lives depended on their mechanical expertise. Good. Let's get started. The next 4 days were a blur of precision work and exhaustion. McKinley's team removed engines, modified superchargers, enlarged intercoolers, reassembled everything, tested, adjusted, tested again. They worked 16-hour shifts, catching a few hours of sleep on cots in the hangar between engine runs. Other squadron mechanics watched with a mixture of curiosity and skepticism. Some volunteered to help. Others kept their distance, not wanting to be associated with unauthorized modifications if things went wrong. By October 7th, 6 P-51 seconds had been modified. Aircraft 44-14826, the original test bird, and 5 others, carefully selected from the squadron's inventory. They sat on the flight line, externally identical to every other Mustang, but internally transformed. Colonel Marcus assembled 6 of his most experienced pilots for a briefing. Captain Anderson was among them, along with 5 other veterans who had been flying combat missions for at least 6 months. Gentlemen, you've all heard the rumors about modified aircraft. Here's the truth. We've installed experimental supercharger modifications on 6 birds. These modifications significantly extend our combat ceiling, allowing us to operate effectively above 40,000 feet. Captain Anderson has test-flown the prototype extensively and reports excellent performance. Marcus gestured to a map on the wall, showing recent German reconnaissance activity. Starting tomorrow, U-6 will fly high-altitude combat air patrols using the modified aircraft. Your mission is to intercept German reconnaissance birds operating above 40,000 feet. You'll also collect operational data on engine, performance, fuel consumption, and handling characteristics at altitude. A captain named Mitchell, a quiet Texan who had shot down 7 German fighters, raised his hand. "Sir, what's the failure risk on these modifications?" "Unknown. Sergeant McKinley is confident in his work, and the test flights have been flawless. But these engines haven't been combat-proven. You'll all be flying with that uncertainty." Another pilot, Lieutenant O'Connor from Boston, grinned. "Sir, I've been watching those German bastards fly around up there for months, taking pictures, radioing our positions, completely untouchable. If there's a chance we can finally reach them, I'll take the risk." The others nodded agreement. Fighter pilots were not, by temperament, people who avoided calculated risks. "One more thing," Marcus said. "If you experience any engine problems, any unusual vibrations, overheating, loss of power, anything, you're to break off immediately and return to base. We need to know about failures before they become fatal. Clear?" "Clear, sir." The first combat mission with modified aircraft launched at 0630 on October 8, 1944. 6 P-51 seconds, each carrying a pilot who understood they were flying experimental equipment, climbing into the cold dawn sky over England. Captain Mitchell led the flight. They climbed through layers of clouds, through 20,000 feet, 30,000, continuing to climb where standard P-51 seconds would have been struggling. At 38,000 feet, Mitchell keyed his radio. "Falcon flight, how are your birds running?" 5 voices reported back. All engines operating normally. All aircraft still climbing strongly. At 40,000 feet, they leveled off and began a patrol pattern over the Dutch coast, exactly where German reconnaissance aircraft had been spotted regularly. The modified Mustangs cruised comfortably at an altitude that would have been barely reachable for standard P-51 seconds. They did not have to wait long. At 0745, a ground radar station radioed a contact. "High-altitude target, bearing 270, altitude estimated at 41,000 feet. Mitchell turned the flight toward the contact. They climbed to 41,500 feet above the German aircraft, positioning themselves for a bounce, an attack from above and behind. Mitchell spotted it first. A Junkers Ju-86P, a specialized high-altitude reconnaissance variant with long, narrow wings and a pressurized cabin. It was cruising along, probably photographing Allied positions, its crew confident that no Allied fighter could reach them. They were wrong. Mitchell positioned his flight for the attack, using the sun to mask their approach. At 3,000 yards, he rolled inverted and pulled through, diving toward the German aircraft with the massive speed advantage that altitude provided. The Junkers crew never saw them coming, Mitchell opened fire at 800 yards, his 650 caliber machine guns tearing into the German aircraft's fuselage. Pieces flew off. The port engine erupted in flame. The Junkers twisted into a death spiral, falling from the sky like a wounded bird. It was the first German high-altitude reconnaissance aircraft shot down by American fighters in months, and it would not be the last. Over the next 30 days, the 6 modified P-51 seconds flew 42 high-altitude combat air patrols. They intercepted and shot down 12 German reconnaissance aircraft, damaged 4 others, and forced countless more to abandon their missions when they detected American fighters at altitudes they had previously considered safe. The engine modifications proved reliable in combat conditions. There were no catastrophic failures, no in-flight emergencies caused by the supercharger changes. Fuel consumption was higher than standard at extreme altitude, limiting patrol time, but acceptable. Engine temperatures remained within safe limits, even during sustained high-altitude operations. More importantly, the strategic impact was immediate. German intelligence noted in captured documents that Allied fighter capabilities at high altitude had increased dramatically. Reconnaissance missions were scaled back. Photographic coverage of Allied positions decreased significantly. The intelligence advantage that Germany had enjoyed above 40,000 feet evaporated within a month. By mid-November 1944, 8th Air Force Command authorized squadron-wide implementation of McKinley's modifications. Engineering teams were dispatched to fighter squadrons across England, carrying the technical documentation that McKinley had prepared, training mechanics on the modification procedures. McKinley himself became something of a celebrity in maintenance circles. Mechanics who had initially been skeptical now sought his advice on other potential improvements. Officers who had dismissed him as just another enlisted man now treated him with respect bordering on deference. The official recognition came in December. Colonel Marcus called McKinley to his office, and this time the meeting was not about explaining unauthorized modifications. It was about a small velvet box containing a Bronze Star medal. "Sergeant McKinley," Marcus said formally, reading from a citation document, "for exceptionally meritorious achievement in connection with military operations against the enemy." Sergeant McKinley, through his initiative, technical expertise, and dedication to improving combat effectiveness, developed supercharger modifications that significantly extended the operational ceiling of P-51 aircraft. These modifications resulted in the interception and destruction of multiple enemy reconnaissance aircraft and provided critical tactical advantage to Allied forces. His actions reflect great credit upon himself and the United States Army Air Forces. Marcus pinned the medal to McKinley's uniform. "Hell of a job, Sergeant. You changed the air war." McKinley, normally confident to the point of brashness, found himself momentarily speechless. "Thank you, sir. I saw a problem and tried to fix it. That's what good soldiers do. They see problems and fix them, even when they're not supposed to, even when it could get them court-martialed." Marcus smiled. "Between you and me, Sergeant, I'm glad you didn't ask permission first. If you had gone through official channels, we'd still be waiting for approval while Germans took pictures from 45,000 feet. The story of McKinley's modifications spread through the Army Air Forces and beyond. Aviation magazines published articles about the mechanics supercharger that had extended P-51 capabilities. Post-war histories would note the modification as an example of field innovation improving combat effectiveness. But perhaps the most telling acknowledgement came from an unexpected source. In late December, McKinley received a letter from the Packard Motor Car Company, the firm that built the Merlin engines under license in the United States. The letter was from their chief engineer. "Dear Sergeant McKinley, we have reviewed the technical documentation of your supercharger modifications with great interest. Your approach to increasing high-altitude performance through impeller geometry changes and intercooler enhancement demonstrates sophisticated understanding of thermodynamic principles. We would like to invite you to consult with our engineering team regarding potential incorporation of similar design principles in future engine variants. We believe your practical experience could provide valuable insights for our development program. McKinley showed the letter to Anderson one evening in the officers' mess, where the captain had invited him for a drink. Regulations about fraternization between officers and enlisted men temporarily suspended in recognition of what they had accomplished together. "They want to hire you," Anderson said, reading through the letter. "I'm a mechanic. You're an engineer who got his degree in maintenance hangars instead of universities. That's what this letter is saying. They recognize it even if you don't." McKinley folded the letter carefully and put it in his pocket. "Maybe, but right now we've got a war to finish." The war continued for another 5 months. McKinley's modifications spread through the 8th Air Force and eventually to P-51 units in other theaters. Not every squadron adopted them. Some commanders preferred to stick with standard configurations, uncomfortable with field modifications, even when they were officially sanctioned. But enough units implemented the changes that Allied high-altitude capabilities improved dramatically across Europe. German reconnaissance became increasingly difficult. Luftwaffe pilots reported encountering American fighters at altitudes that should have been impossible. The psychological impact was significant. German aircrew morale, already declining as the Reich collapsed, suffered further when even the sanctuary of extreme altitude proved vulnerable to American fighters. Captain Anderson continued flying combat missions through the winter and spring of 1945, racking up 5 more kills in his modified P-51. He survived the war and returned to the United States in June 1945, mustering out as a major. He would later write a memoir about his experiences, devoting an entire chapter to McKinley's modifications and their impact on high-altitude combat. Technical Sergeant McKinley remained with his squadron until VE Day in May 1945. When the war in Europe ended, he had a decision to make. The Army Air Forces offered him a position at Wright Field in Ohio, working on advanced aircraft development. Packard renewed their job offer, promising a comfortable salary and the chance to work on cutting-edge engine technology. McKinley surprised everyone by declining both offers. He returned to Detroit, to the auto shop he had worked at before the war, and resumed his life as a civilian mechanic. When asked why he had turned down prestigious opportunities, his answer was simple. "I like working on cars. I like the smell of oil and gasoline, the feel of a wrench in my hand, the satisfaction of fixing something that's broken. I don't need a fancy title or a big salary. I just want to do work I'm good at, work that matters." He never spoke much about his wartime experiences. His customers at the auto shop knew he had been a mechanic in the Army Air Forces, but few knew the details. The Bronze Star Medal sat in a drawer at home, rarely displayed. McKinley was not the type of man who sought recognition or told war stories, but he kept in touch with Anderson. They exchanged letters several times a year, meeting occasionally when Anderson's business travel brought him through Detroit. They would have dinner, talk about engines and aircraft, reminisce about that September morning in 1944 when they had test-flown an unauthorized modification that changed the air war. In 1953, 8 years after the war ended, McKinley received an unexpected visitor at his Detroit auto shop. A man in his 40s, well-dressed, carrying a briefcase, introduced himself as Dr. Friedrich Müller, an aeronautical engineer from West Germany. "Mr. McKinley, I hope you will forgive this intrusion. I have travelled some distance to meet you." McKinley wiped oil from his hands with a shop rag. "Can I help you with something, Dr. Müller? I am working on a research project examining innovations in aircraft technology during World War II. Your supercharger modifications for the P-51 are of particular interest. I was hoping you might answer some technical questions." They sat in McKinley's small office, surrounded by invoices and parts, catalogues, and talked for 2 hours. Müller asked detailed questions about impeller geometry, intercooler design, thermal management. McKinley answered honestly, describing his thought process, the calculations he had made, the trial and error that had led to the final design. At the end of the conversation, Müller closed his notebook and looked at McKinley with an expression somewhere between admiration and sadness. You know, Mr. McKinley, we had mechanics in the Luftwaffe who also recognized the high-altitude limitations of our superchargers. They also proposed modifications, but the German system did not permit field innovations. Everything had to go through official channels, through engineering committees and approval processes. By the time modifications were approved, if they were approved at all, it was too late. He paused, choosing his words carefully. The American military system had something the German system lacked. It allowed initiative from below. It permitted sergeants to challenge established designs. It trusted that good ideas could come from unexpected places. That flexibility, that willingness to innovate in the field, that was as much a weapon as any aircraft or bomb. McKinley thought about that after Müller left. He had never considered his actions in those terms. He had just seen a problem and fixed it, using skills he had learned building racing engines in Detroit, applying them to military aircraft, because that is what the situation required. But maybe Müller was right. Maybe the ability to innovate, to question established procedures, to take calculated risks, maybe that was part of what separated the Allied and Axis military systems. Not just material superiority, though that mattered. Not just manpower, though that mattered too. But a culture that valued individual initiative, that allowed people at all levels to contribute ideas, that recognized that the best solutions sometimes came from people working directly with the problems rather than from distant bureaucracies. In 1968, 24 years after his modifications had extended P-51 combat capabilities, McKinley attended a reunion of his wartime squadron. Colonel Marcus was there, now a retired brigadier general, Captain Anderson, now a successful aerospace executive, and dozens of other pilots and mechanics who had served together in England during the war. They gathered at a hotel in Washington, D.C., old men now, greying and thicker around the waist, but still connected by shared experience, by memories of cold English mornings and the thunder of Merlin engines starting up at dawn. During dinner, Marcus stood to give a speech. "Gentlemen, we're here tonight to remember what we accomplished together. The missions flown, the battles won, the friends lost. But I want to talk about something specific. I want to talk about the importance of trusting the people who do the work." He gestured toward McKinley, who sat at a table with other maintenance personnel. In October 1944, Sergeant McKinley came to me with an impossible claim. He said he could extend our combat ceiling by 4,000 feet using unauthorized modifications. By every regulation in the book, I should have shut him down immediately. But I didn't, because sometimes the book is wrong and the mechanic is right. Marcus paused, letting that sink in. How many lives did those modifications save? How many reconnaissance missions did we intercept because we could finally reach 40,000 feet? How many convoys didn't get hit? How many airfields didn't get photographed? How many bomber formations didn't get jumped by fighters vectored in by high-altitude spotters? We'll never know the exact numbers, but I know this. Sergeant McKinley's initiative changed the air war, and it happened because we were willing to trust a mechanic who saw a problem and fixed it. The room erupted in applause. McKinley, embarrassed by the sighting, attention, raised his hand in acknowledgement but did not stand. He had never been comfortable with praise, never sought recognition for work he considered just doing his job. Later that night, Anderson found McKinley on the hotel balcony, smoking a cigarette and looking out at the Washington lights. "You okay, Jim?" "Yeah, I'm fine. Just thinking." "About what?" McKinley took a drag on his cigarette. "About how close it came to not happening. If you had refused to test fly that first modification, if Marcus had followed regulations and shut me down, if those first test flights had failed. It was all so contingent, you know? So many things could have gone wrong." Anderson leaned against the balcony railing. "But they didn't go wrong. You did the calculations correctly. You built the modifications properly. You took a risk, sure, but it was a calculated risk based on solid engineering principles. That's not luck, that's skill." "Still feels like luck sometimes." "Well, for what? It's worth. I'm glad you took that risk. I'm glad you saw a problem and refused to accept that it couldn't be solved. That's what made the difference, Jim. Not the specific technical solution, though that was brilliant, but the mindset that said there has to be a better way, and I'm going to find it, even if it means breaking some rules. They stood in comfortable silence for a few minutes, two old friends thinking about events that had happened a quarter century earlier but still felt immediate, still shaped who they had become. Technical Sergeant James McKinley died in 1989 at age 71 in Detroit, surrounded by family. His obituary in the Detroit Free Press mentioned his military service briefly, noting that he had received a Bronze Star for technical innovations during World War II. It did not detail what those innovations were or how they had extended P-51 capabilities at a critical moment in the air war. His funeral was attended by family, friends, former customers from his auto shop, and three men who had travelled significant distances to be there. Robert Anderson, now 82, who had test-flown McKinley's first modification and trusted him when trust mattered most. Colonel Marcus's son, representing his father who had passed away in 1985, bringing the general's personal effects, including a letter thanking McKinley for his initiative and courage, and Dr. Friedrich Müller, the German engineer who had visited McKinley's shop in 1953 and never forgotten the conversation about innovation and initiative. At the graveside, Anderson spoke briefly. Jim McKinley was a mechanic. That's how he saw himself, and that's what he loved being. But he was also an innovator, a problem solver, someone who refused to accept limitations just because that's how things had always been done. In September 1944, he looked at an engine that every expert said had reached its maximum potential, and he said, "I can make this better." And he did. That's the legacy Jim leaves behind. Not just specific technical achievements, though those were considerable, but the example of someone who saw a problem and had the courage to fix it, even when it meant taking risks, even when it meant challenging established wisdom. The story of McKinley's supercharger modifications eventually made it into aviation history books, usually as a footnote about field innovations during World War II. But the people who had been there, who had flown the modified aircraft, or maintained them, or commanded the squadrons that used them, they understood the deeper significance. It was not just about superchargers or combat ceilings or intercepting reconnaissance aircraft. It was about a system that allowed initiative, that trusted people to solve problems creatively, that recognized that good ideas could come from anywhere if you were willing to listen. The P-51 Mustang is remembered as one of the great fighter aircraft of World War II. Its combination of long range, high speed, and effective armament made it the perfect escort fighter for bomber formations striking deep into Germany. But for a brief period in late 1944 and early 1945, some P-51 seconds were even more capable than historians typically acknowledge. They could reach altitudes that standard Mustangs could not, operating in airspace that Allied fighters had previously been unable to access. They intercepted German reconnaissance aircraft that had been untouchable for months. They provided high-altitude combat air patrol that protected bomber formations from being tracked and targeted. And all of that happened because one mechanic from Detroit refused to accept that a problem was unsolvable, because one captain was willing to test fly an unauthorized modification, because one colonel had the courage to trust his people instead of blindly following regulations. In the years after the war, aviation, technology advanced rapidly. Jet engines replaced piston engines. Supersonic flight became routine. The era of propeller-driven fighters ended. The specific technical solutions that McKinley had developed became obsolete within a few years, replaced by entirely new propulsion systems. But the principle behind his innovation never became obsolete. The idea that people working directly with problems often see solutions that distant experts miss. The recognition that innovation requires taking calculated risks. The understanding that rigid adherence to established procedures can be an obstacle to progress. These lessons transcended the specific technology of superchargers and piston engines. They applied to any complex system where problems needed solving and established approaches were insufficient. The modified P-51 seconds flew their last combat missions in May 1945 as the war in Europe ended. After VE Day, most were returned to standard configuration, the experimental supercharger modifications removed, the engines rebuilt to factory specifications. The Army Air Forces wanted standardization for the occupation period and the anticipated conflict with Japan. A few modified aircraft were retained for testing and evaluation. One was sent to Wright Field for detailed engineering analysis. The Packard engineers who examined it confirmed what McKinley had intuitively understood. His modifications provided a steeper compression curve, optimized for high-altitude operation, and his intercooler enlargement addressed the thermal limitations that had restricted standard Merlin performance above 35,000 feet. The engineering report concluded with an observation that McKinley would have appreciated. The modifications demonstrate sophisticated understanding of thermodynamic principles and represent creative solution of complex technical problems. While not suitable for mass production in their current form, the underlying concepts provide valuable insights for future engine development. Recommend further research into high-altitude optimization of supercharger systems. In other words, the mechanic had been right. The experts just needed time to catch up. Today, aviation museums occasionally display P-51 Mustangs with placards describing their specifications and combat record. Very few mention the brief period when some Mustangs could reach 42,000 feet, the result of unauthorized modifications by a sergeant mechanic who saw a problem and refused to accept that it could not be solved. But the pilots who flew those modified aircraft never forgot. The mechanics who installed McKinley's supercharger changes never forgot. The commanders who trusted their people enough to authorize field innovations never forgot. They understood something that goes beyond technical specifications and combat statistics. They understood that winning requires more than superior equipment and greater numbers. It requires a culture that values initiative, that trusts people at all levels to contribute, that recognizes that the best solutions often come from unexpected places. Sergeant James McKinley gave the P-51 Mustang the ability to fight at 42,000 feet. But more importantly, he demonstrated what becomes possible when institutions are flexible enough to accept innovation from below, when leaders are courageous enough to take calculated risks, when mechanics are empowered to challenge engineering orthodoxy. That was his real legacy, not the specific modifications to supercharger impellers and intercoolers, though those were brilliant in their own right, but the example of someone who saw a limitation and refused to accept it, who had the expertise to develop a solution and the courage to implement it without permission, who trusted his own judgment even when it meant breaking rules. In September 1944, Captain Anderson sat in his cockpit, watching German aircraft operate at altitudes he could not reach. 3 weeks later, thanks to one mechanic's initiative, he was intercepting those aircraft at 42,000 feet. That transformation happened because people were willing to take risks, to trust each other, to prioritize mission success over regulatory compliance. Wars are won by material superiority and numerical advantage, but they are also won by flexibility, initiative, and the courage to innovate when innovation is needed. Sergeant McKinley's supercharger modifications proved that principle in the most direct way possible, by putting American fighters at altitudes everyone had said were impossible to reach. And in doing so, he changed not just the air war, but the understanding of what becomes possible when you trust people to solve problems creatively, even when, especially when, they are not supposed to. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.